Okay, hello, Ayman. We start our lesson. The theme of our lecture is basic of the technology of assembly processes. Please write down to your notes this theme and the plan of our lecture. So we have theme 11. So 11.1, basic concepts and definitions. 11.2, technological methods for ensuring assembly accuracy. Technological methods for ensuring assembly accuracy. 11.3, features of technical regulation of assembly operations. Features of technical regulations of assembly operations. And 11.4, fundamentals of assembly process design. So we start the first item, 11.1. Basic concepts and definitions. So assembly is one of the final stage of machine production, in which a finished product is obtained by connecting individual parts, components, and assemblies in a certain sequence. The quality of the machine depends to a large extent on the quality of the assembly work. The complexity of assembly in the manufacture of most machines is very significant. It can reach from 30 to 50% of the total labor intensity. All work of the assembly process is divided into separate successive stages: assembly of nodes, assembly of mechanism, assembly of aggregates, etc. Parts arrive at the assembly after the final inspection, but before assembly, individual parts must be sorted by weight. For example, pistons and connecting rods of internal combustion engines, fast rotating parts, crankshafts, flywheels, pulleys, etc. must be pre-balanced. Before assembly, if necessary, fitting and fitting work, painting individual parts, washing, cleaning, and lubricating, if necessary, according to technological specifications, mating parts are performed. And now classification of compounds. When assembling, the following types of connections are distinguished: fixed, detachable, and one piece, movable, detachable, and one piece. So first, fixed detachable compounds. Fixed detachable compounds are those that can, after assembly, be disassembled without damaging the connected parts. Examples of fixed detachable connections or compounds are threaded, cade, etc. connections. Threaded connections, for example. Fixed one-piece compounds include those whose separation after assembly is impossible without damaging or destroying the articulated parts. These compounds are obtained by welding, gluing, soldering, expanding, etc. Next type of compounds is moving detachable compounds. Include those in which the parts are connected by a moving feed, for example, gears. Rolling bearings, riveted bush roller chains, etc. belong the movable one-piece compounds. Please write down to your notes these 4 types of compounds. First type, fixed detachable compounds. Second type, fixed one-piece compounds. Moving detachable compounds and movable one-piece compounds. And now we start item 11.2, technological methods for ensuring assembly accuracy. Technological methods for ensuring assembly accuracy. Assembly accuracy is the most important condition for obtaining a product with specified quality indicators. One more time, please write down to your notes what is the mean assembly accuracy. Assembly accuracy is the most important condition for obtaining a product with specified quality indicators. It is impossible to completely assemble a unit or machine as a whole. Since during assembly it is impossible to avoid errors in the relative position of parts, non-observance of the necessary tension gaps, increased deformations, etc. in combination. Errors. In the performance of assembly operations are caused by the following main reasons. Deviation from the accuracy of dimensions, geometric shape, and relative position of the surfaces of the connected parts. Deviation from the accuracy of dimensions, geometric shape, and relative position of the surface of the connected parts. Imperfection of the surface quality of parts. Imperfection of the surface quality of parts. Deviation from the installation accuracy, orientation, and fastening of parts during assembly. Deviation from the installation accuracy, orientation, and fastening of parts during assembly. Residual stress in the material causing deformation, violation of gaps and landings, and interferences and fits. Residual stresses in the material causing deformation, violation of interferences and fits. Geometric inaccuracies of assembly equipment, tools, and equipment. Geometric inaccuracies of assembly equipment, tools, and equipment. And the last one, incorrect settings and operating modes of the assembly equipment. Incorrect settings and operating modes of the assembly equipment. The most advanced assembly techniques can be used when there are interchangeable parts to be assembled. In this case, the assembly process is the easiest of perform without the use of additional fitting and fitting operations. However, this is only possible under conditions of mass and large-scale production, when through perfect processing and control methods, interchangeable parts can be obtained. The interchangeability of parts is ensured by manufacturing them with the required dimensions within tolerances corresponding to a given accuracy class. With the required dimensions within tolerances corresponding to a given accuracy class. The theory of dimensional chains is described in detail in the course Interchangeability, Standardization, and Technical Measurements. Consider a dimensional chain like in figure 11.1. In this figure you can see the parts in the dimensional chain and the scheme of the dimensional chain. A1, A2, A3, A4, it's a links of dimensional chain. So the error of the closing link, A3, it's a closing link in this scheme, is determined based on the equation 11.1. We use these equations to find the error of the closing link A3. A3 in this scheme, it's clearance. This clearance, it's A3. It's a closing link. From these equations, we can find omega A3. And we use the formula 11.2. Or according to the condition assembly of the unit, we use the formula 11.3. Where in these formulas, omega A2, omega A3, omega A4, it's errors of the links A2, link A3, and link A4. Those are errors of the links in this scheme. Please write down to your notes the formula, special 11.2. Thus, we can formulate the rules for constructing a dimensional chain in a general form. The error in the size of the closing link or master link of the dimensional chain is equal to the algebraic sum of the errors in the dimensions of the constituent links of this chain. And we use formula 11.4 is the sum of the errors in the dimensions of the constituent links of these chains. Is the sum of the omega suffix I. Where omega suffix I is the size error of the ith link. N in this formula from n minus 1 to from I is equal 1 to I equal n minus 1. So n the number of links of the dimensional chain, in particular the closing link. In particular the closing link. It's all links without closing link. The tolerance for the closing link of the dimensional chain is equal to the algebraic sum of the tolerances for the dimensions of the constituent links of this chain. In formula 11.5 that you can see in this slide, delta suffix I is the tolerance of the ith chain link. It's tolerance of the ith chain link. For example, it's the sum of the tolerance of first link, second link, third link, and nth link. We use the tolerances of all links of this chain without closing link or master link. Our closing link is A3, so it's suffix 3 in this form. Delta suffix 3, it's tolerance of the closing link. The required assembly accuracy must be achieved by appropriate technological assembly methods. Please write down to your notes the formulas 11.4, 11.5, and what is the mean omega suffix I, n, and delta suffix I. The components of these formulas, of those formulas. Write down to your notes. And next slide, technological methods of selection. We use a decal of technological methods to ensure the specific accuracy of the selection. The method of fitting, adjustment, repeated interchangeability, partial interchangeability, and group interchangeability. In figure 11.2, you can see in figure A, it's a fit, B, adjustment, C, group interchangeability, 1 and 2, it's sorting groups. Fitting assembly, it is used as a rule in single and small scale production. The specific accuracy is achieved by removing the required layer of material from one of the connected parts. The specific gap or clearance A3 is achieved by fitting part 1. It's delta 3, its clearance between two parts, can achieve it by fitting part 1. Part 1, this part. By scraping, lapping, etc. The allowance for fitting is determined by the formula 11.6 or 11.7. Delta, in this figure, you can see delta suffix 0 and delta suffix 3. Delta suffix 3, it's a clearance between two parts. And Z, it's the allowance for fitting. Where in these formulas 11.6 and 11.7, where delta suffix D maximum delta suffix d maximum. The maximum tolerance of the closing link assigned taking into account the extended tolerance field for the dimensions of the connected parts. And delta suffix d is the specific tolerance for the closing link. Please write down to your notes the scheme on the figure 11.2, scheme A, and the formulas 11.6 and 11.7, and components of the formulas, delta D maximum and delta D. Assembly according to method of regulation. Assembly according to the method of regulation. The essence of the method is that the specific accuracy of the size of the closing or master link is achieved by changing the size of the compensating links, compensating links that's called compensator. A preselected element, the executive size of which has an increased tolerance field, with which the required size of the closing or master link is achieved. As shown in figure 11.2, this figure 11.2, in figure B, to obtain the necessary clearance in the connection, a compensating ring K is used. Let's see in this figure the compensated link K. It's a compensated ring K. Gasket adjusted screws, bushings, etc. are used as a compensator. This method is widely used in mechanical engineering since it has wide versatility, does not depend on the number of links in the dimensional chain. The tolerance for the master link or closing link, and the type of production. With the help of compensators, it is possible to regulate not only the tolerance for the closing or master link during the assembly process, but also the wear of the main part during the operation of the machine. Assembly according to the method of complete interchangeability, it is used in the event that the tolerance for the master link is calculated according to the limit values of tolerances for the dimensions of the constituent links. We used the formula 11.8. Write down this formula. At the same time, the assembly process is simplified from a technological point of view of science. It is reduced only to the selection and connection of component links or parts without additional adjustment. Due to the absence of fitting operations, it is easy to set up an automatic assembly line. However, the machining process becomes more complicated since it requires the appointment of very tight tolerances of the dimensions of the constituent links. Thus, the method is best used in large-scale and mass production for two-link dimensional chains, for example, in combinations of shaft bushing, shaft bearings, etc. For multi-link chains, this method is time-consuming and economically inexpedient. Assembly according to the method of incomplete interchangeability, it differs from the previous method in that in order to reduce the cost of assembly, the tolerances on the dimensions of the constituent links are deliberately increased. If we assume that the actual deviations in the dimensions of the constituent links are random independent variables, then using the summation method according to probability theory to calculate the tolerance for the closing link, we obtain the formula 11.9. In this formula, K, where K is the risk coefficient that characterizes the percentage of output of the values of the closing link beyond the established tolerance. At K is equal 3, the risk of marriage is 0.2%. A is the coefficient characterizing the distribution law. Let us consider the expediency of increasing the tolerance fields for the constituent links of the chain when assembling according to the method of incomplete interchangeability using a specific example. Assume that the dimensional chain consists of 5 links. We have 5 links of the dimensional chain. The tolerance for the master link or closing link is set to 0.12 millimeters. In this case, the tolerance for the closing link will calculate by the formula. We use 0.12 millimeters, it's tolerance of the closing link or master link. The number of links, we have the five links, 5 minus 1, and we have 0.03 millimeters. We assume that the size scattering law is close to Simpson's law. That is, K is equal 3, A is equal 1 divided by B, and the average tolerance for the closing or master link, we use the formula like 11.9, and we have delta is equal 0.06 millimeters. We use A is 1 divided by 6, N is equal 5, we have 5 links, delta is equal 0.12 delta, it's a tolerance of the master or closing link, 0.12, and K, its coefficient is equal 3. Thus, the tolerance for the closing link with the same accuracy can be increased by almost 2 times. Assembly according to this method is advisable in serial and mass production for dimensional chains. Assembly by the method of group interchangeability. The essence of this method, also called selective assembly, is that parts are manufactured with increased tolerances. Before assembly, the missing parts are sorted into size groups with the same tolerances. In practice, production or multiplied tolerances are usually determined, increasing them by a multiply of times. On figure 11.2, it shows the layout of the tolerances of the connected parts. It's figure 11.2 C. So in formulas 11.12 and 11.13, where K is the tolerance multiplier, or the number of parts sorted groups. In this case, K is equal to delta suffix 1 and delta suffix 2 are respectively the tolerances for the connected parts. The total field of technological tolerances is equal to the sum of the delta suffix 1k and delta suffix 2k. And it's equal k multiplied by sum of the delta 1 and delta 2, where k is calculated by the formula 11.15. In this example, k is equal to, it is obvious that the order to ensure the same for all joints of the average interference A It is necessary that the equality delta 1 is equal delta 2. Thus, within the same size group, the assembly of parts is carried out according to the method of complete interchangeability. The selective assembly method ensures the highest accuracy. It is used when assembling precision connection, plunger pairs, connecting rod and piston groups, etc. And now we start, if you have the questions about the previous item, we start item 11.3, Features of Technological Regulation of Assembly Operations. Write down to your notes this unit, the name of this unit. Features of Technological Regulation of Assembly Operations. Fitting and assembly work consist of certain operations. For example, to cut metal manually with a hacksaw, you need to mark the workpiece into separate parts, take a hacksaw and get ready for work. Install a hacksaw in place of cutting. Cut off the workpiece. Clean the hacksaw blade from chips and put down the tool. So, in this example, as in other plumbing and assembly work, it is difficult to clearly distinguish between main and auxiliary time. Receptions are performed as a single set of works. Therefore, when rationing assembly work, incomplete operational time is allocated and the time for installing the removing parts, time for installing and removing parts is determined separately, since these methods, when performing manual work, are independent in nature and duration. With this in mind, the formula for determining the artificial assembly time will take the form 11.17. In this form, sum of TPO, it's partial operational time, T in, time of installation and removal of the part or assembly, T main, time of organizational and technical maintenance of the workplace. Maintenance. Time of organizational and technical maintenance of the workplace. And T suffix B, the time of breaks for rest and physical needs. So sum of these four parts, it's time for artificial assembly time. Artificial assembly time. Rationing of individual elements of artificial assembly time is carried out according to normative reference books compiled on the basis of timing of assembly operations at advanced machine building enterprises. In serial production, the preparatory and final time of assembly work is included in the norm of time. The technical norm of time for a batch of products is determined by the formula 11.18. In this formula, T suffix AA, TPF, it's preparatory and final time for assembly work. It is from 10 to 15 minutes. For plumbing, 5-6 minutes. N is the batch size. And T batch, TAA, it's artificial assembly time. Artificial assembly time. And item 11.4, fundamentals of assembly process design. Fundamentals of assembly process design. To design assembly operations, you need to find the organizational and technological properties of the assembly. The assembly cycle is the calculated time found, shift, month, year, divided by the release program for the corresponding period with formula 11.19. N, it's a release program of the corresponding period, and QFT, it's time found. It's time found. Organizational forms of assembly depend on the tact and type of production. Distinguish between stationary and inline organization of the assembly. Stationary assembly is characterized by the performance of assembly operations at permanent stationary workplace to which parts, assemblies, and components are supplied. This form of assembly organization is used in single and small-scale production. Stationary assembly requires highly skilled workers to perform assembly operations. In-time assembly is characterized by the execution of assembly processes on mobile or stationary specialized workplaces of the production line. Mobile inline assembly is performed by transferring the object to be assembled along a continuously or intermittently moving assembly conveyor, as well as moving it using mechanical devices or manually or manually on roller tables, carts, trays, etc. This form of assembly organization is used in serial and mass production. Stationary inline assembly is performed at stationary workstation. At the same time, they perform specialized types of assembly work, moving from one post stand to another. This form of assembly is widely used in series production. The duration of the assembly on the production line is determined by the formula 11.20. In this formula, n suffix j, the number of jobs stands on the assembly line. And tau, it's assembly cycle. Tau, it's assembly cycle. The number of jobs on the assembly line is determined by the number of assembly and control operations, as well as the number of spare sets, for example, for fitting, grinding, etc. Assembly productivity at a given workplace is determined by the formula 11.21, where n suffix p, the number of assembled products for the planned period of time, shift, month, year. Q suffix ft, the actual font of time for the same period of time. R suffix po, piece time for execution of this assembly operation. The load factor of jobs is determined by the formula 11.22. Total load factor of the production line. Another parameters that characterize the assembly process. It's total load factor of the production line, the coefficient of labor intensity of the assembly process, the assembly process cost factor. Please write down these parameters to your note. The assembly process cost factor is applied in those cases when the enterprise receives machine components through cooperation. Under the technological operation of the assembly is meant the completed part of the assembly process carried out at one workplace by one or group of workers. Assembly operations are divided into transitions, setups, and techniques. The assembly transition is the completed part of the operation performed without changing the tool or fixture. Transitions can be technological and auxiliary. Auxiliary transitions, as in machining, are not specifically connected to the quantitative and qualitative configurations of the assembly object, but serve only the perform technological transitions. Transitions are divided into separate techniques, parts of the transitions consisting of simple movements of the worker or tool. And the last what we need to write down is a set. A set is called each individual action to give the collected objects a certain relative position. When designing the type of production of organizational forms of assembly are taken into account, for example, in the case of inline assembly, the duration of the operation must be equal to or a multiply of the cycle of the assembly process. When assembling, it is necessary to pay special attention to the accuracy of basing and scheme of fixing the basic elements. Choose technological equipment, fixture, tool. Determine the modes of performing operations, the norms of time, the category of work, etc. The effectiveness of the developed assembly process is evaluated by labor intensity, cost, or by coefficients of labor intensity and assembly cost. In order to increase the efficiency of assembly processes, it is necessary to strive as much as possible to reduce manual methods, to expand the use of mechanization and automatization of processes. So we finished our material of our lection. Have your questions about our lections? Of course, you can find our presentation in our Telegram group, in our site. You can find the presentation, and if you have the question, please write down it to our Telegram group. So our lesson is finished. Goodbye, see you next week.